is page 30 in your workbooks. It's the retrieval for lesson 3. So yesterday we talked about exponential equations, and we looked at Shelley the tortoise and the exponential equation 2 to the power of x. So today what we're looking at is exponential equations, but solving exponential equations. So for all of these here, we have two sides to our equations. Some of them have exponentials on each side, and we want to look at how do we solve that. So before we even jump into number 1, I want us to think about, say I had 3 to the power of x equals 3 to the 4th. Okay, so x, since it's in the exponent, and over here, since 4 is in the exponent, and my bases are the same, right? My bases are both 3. In this case, x has to be equal to 4. If my bases are the same, the exponents also have to be the same. So here it's very simple because we just have an x and a 4. Okay, we're going to apply that same idea down here for number 1. All right, so my bases are both 3. When that's the case, I can just set the exponents equal to each other because my bases are the same. So we would have 4x plus 5 equals, the other exponent is 7x minus 13. And at this point, it's now a regular plain old equation like we're used to. Okay, so I'm going to subtract 4x to move the x's to one side. So we have 5 equals 4x minus, or 7x minus 4x is 3x. Bring down the minus 13. Add 13 to each side. Oops. So here we have 18 equals 3x. And then divide each side by 3. So 18 over 3 is 6. So x is equal to 6. Okay, so once we got rid of the bases of 3, this was like any other regular old equation. Looking at number 2, then it's the same idea. My base is 5 for both of them. When my bases are the same, that means the exponents must be equal to each other. Okay, so I can just set the exponents equal to each other. So 1 minus x is equal to x plus 9. And now I can solve. So I'm going to go ahead and move this x here. Since it's subtracting, I'm going to add it. So the left side, I just have 1. X plus another x is 2x plus the 9. Subtract 9. So we have negative 8 equals 2x. Dividing each side by 2. So negative 8 over 2 is negative 4. Okay, so these were both examples of what to do when our bases are the same. So the next ones we'll see, our bases are not the same. So number 4 here, one has a base of 4 and one has a base of 16. Because the bases aren't the same, I can't just set the exponents equal to each other. But what I want to do is I want to try and rewrite one of them, or sometimes both of them, so that they have the same base. Okay, so what I want to think about here is I could write 16 as something with a base of 4, because 4 to the second power is 16. Okay, so I'm going to replace 16 with 4 to the second power because they're equal. All right, and then it's still to the 2x plus 5. So I'm not changing the value of anything because 4 squared is equal to 16. All right, and on the left, we didn't do anything. Okay, and now, see, they have the same base, 4 and 4. So I can set the exponents equal to each other. So we get 2x minus 1. And on the other side, I can't forget about this 2 right here. Okay, so even though the base of 4 is gone, I still have this 2. And what's going to happen is that 2 has to be distributed to the rest of the exponent. Okay, so I'm going to put it in parentheses. So we have to take that into account when we're solving here. So the left is just going to come down for now. And I'm going to distribute this 2. So 2 times 2x is 4x. 2 times 5 is 10. And then we're just solving. So I'm going to subtract 2x from each side. So I get negative 1 equals 2x plus 10. I'm going to subtract the 10. Come up here. So negative 1 and negative 10 makes negative 11. Equals 2x. Dividing by 2. All right, so let's see, if it were 10 over 2, it'd be negative 5. But that's 11, so it'd be negative 5.5. Or you could just leave it as negative 11 over 2 as well. That's okay. All right, so next up here, I see I have an exponential 2 to the 3x, but the left side is not an exponential at all. So we have to remember, we talked a bit yesterday about powers of 2 and how on earth I could get something like 1/8, or we talked more about like a half and a fourth. So we know that negative exponents create this fraction. So what we have to remember is 2 to the power of negative 3 is actually equal to 1/8. Because 2 to the third gives me 8, and the negative turns it into a fraction, so 1/8. Okay, so I'm going to replace 1/8 with 2 to the negative 3. Okay, I can replace it because they are equivalent. They mean the same thing. And the reason we want to do that, this is now helpful because my bases are both 2. And when that's the case, I can set the exponents equal to each other. All right. And after doing that for this one, all there is to do is divide by 3. Negative 3 over 3 is negative 1 equals x. Okay, so what we just did there, 1 through 4, is to help you prepare for the next page, page 31, the ready. So some of these, our exponents are equal to each other, like numbers 1, 2, or, our bases are equal to each other. Like number 1, the bases are both 5. Number 2, the bases are both 7. So they're ready to go and set the exponents equal to each other. Numbers 3 and 4 and 5 and 6 are going to take a little bit of work. Okay, so I have to think about what can I replace so that they have the same base. Okay. So back on page 30 here at the bottom. All right, so this is, should be familiar for us. So we've done stuff like this. So we have f of x, we have a function f, g of x is another function, and they ask us to find several things. So the first one is g of a squared. So we've done this a couple times now. So I'm going to go to g, and anywhere I see an x, which I just see 1 here, I'm going to replace it with a squared. Okay, so instead of x, I'm going to have a squared. And then that still has to be squared here because I'm replacing this whole x with a squared. I still have to do this squared. Minus 3. Right, just to finish out the rest of g. So a squared squared is a to the 4th. And then the minus 3 just comes down. Okay, the other two here are function composition that we've talked about some. So g of f of x, meaning, let's get rid of my stuff here. G of f of x, I'm going to go to g and plug in f. So I have to take this whole thing that is f and plug that in for x in g. Okay, so in place of x, I'm going to put 3x minus 4. Okay, so all I've done at this point is replace this x. I still have to do the rest of it. Squared minus 3. And when we have a binomial like this squared, the 3x minus 4, we're just going to go ahead and leave it like that. Okay, last one. F of g of x. So that means I'm going to go to f, and I'm going to replace x. Here's x. with whatever g is. Well, g is this guy here, so that's going to be plugged in for x. So we have 3, and then I'm replacing x with x squared minus 3 because that's what g is equal to, minus the 4. And this one, since the binomial isn't being squared or anything, it's just this 3 out in front of it, we can go ahead and distribute that and simplify. So 3 times x squared is 3x squared. 3 times negative 3 is negative 9. Then the minus 4 comes down. Okay, so we go ahead and do that because we have some like terms we can combine here. Then negative 9 and negative 4 makes negative 13. Okay, so this is a review then, because we've seen function composition before and we've seen substituting values into functions before. So that is to help you with page 32. So you have 3 functions, f, g, and h, and you just got to pay attention to which ones they're asking for. So you have 6 problems with that. So some of them, they ask you to just plug in b squared, and some of them on the right side is the function composition. So make sure you're paying attention to which function is going where. Okay, so again, that's the end of page 30. You now are going to work on pages 31 and 32.